Dear students, welcome to Sia's digital classes. Today's concept is t-test for single mean. So let us check it out how the concept goes on. So here is a concept we have t-test of significance on single mean. So single mean, to obtain single mean, whenever data we have according to single mean, how the formula or how the procedure we have, let us check it out now. So to test a sample mean x which differs significantly from the hypothetical value mu of the population mean, use the following t-test. So t is equal to x bar minus mu by s by root 10 becomes our formula, that is your test statistics, and it comes out of the t-test. So t-test with n minus 1 degrees of freedom. It's a small sample. So small samples always has degrees of freedom. So with n minus 1 degrees of freedom, we'll consider this test statistics. Now how we have obtained x bar and all, let us check it out, and what are they, let us check it out the formulas. So where n is equal to sample size, so n is the sample size we have, x bar we know the formula, mean formula, that is 1 by n summation xi, sample mean we'll call. Next mu, we know it's a population mean, so population mean for which sample is taken. So these are all the values we will be obtaining from the given question. So again, if s we require s formula we have, if they don't specify directly s value, that is your sample standard deviation value, we can utilize the formula, the usual formula, that is standard deviation for sample mean, that is root over 1 by n minus 1 summation xi minus x bar whole square. What we are utilizing mean and variances formula, the same formulas will follow here for the t-test of single mean. So and as just now I said, degrees of freedom also will be there for small samples. So t-test is a small sample test. So degrees of freedom is n minus 1. So all the details we specified here. Now let us check it out. Its conclusion. So test statistics we have obtained using that test statistics. Whatever the answers we got in test statistics, that is t calculated value, that we have to compare with the critical value, right? So so that we can make a decision whether to accept our null hypothesis or to reject our hypothesis. That decision how we can consider, let us check it out through the points. So if calculated value of mod t is greater than or equal to table value, so calculated value of mod t is nothing but, if at all negative values we are getting, we have to make it into positive, that is mod we need to apply, and the calculated value of t is nothing but, just now we have considered the formula, right? T is equal to x bar minus mu by s by root n, that is your calculated value. So t calculated we call. So that calculated value, if at all it is greater than or equal to table value. Now table value is a t tables will have. So from t tables, according to our LOS and degrees of freedom, we'll check it out that t tables, and we'll obtain the table value or critical value based on LOS and critical and our table degrees of freedom value. We'll obtain that, that is your, here they mentioned, check it out, for n minus 1 degrees of freedom at 5% level, then we reject the hypothesis. So table value, if at all calculated value is greater than the table value, we have to reject the hypothesis, means the H naught will be rejected. So say that the two means differ significantly. If at all we are considering two means, then we will write it as differ significantly, because we are rejecting the null hypothesis here. So that is the one of the decision whenever calculated value is greater than the table value. Then what happens if table value or calculated value is less than the critical value, table value? Let us check it out that decision also. The samples does not seem, we have a conclusion also here. The sample does not seem to have been drawn from the population with the mean mu. If at all the calculated value is greater than the table value, this conclusion we can write. Samples does not seem to have been drawn from the population. We'll consider H naught as samples as dragged out of population always. We'll try to give in null hypothesis. So here we have rejected a null hypothesis, right? So not dragged out of a population we are considering here. as a conclusion. If at all it is rejected. Now, how to accept that one? What are the conditions to accept null hypothesis? Let us check that also. So, if calculated value mod t is less than table value, so table value how you will obtain? Just now I said using your degrees of freedom as well as LOS. So, degrees of freedom, n minus 1 degrees of freedom at 5% level, then accept the hypothesis. So, then we'll accept the null hypothesis H naught. So, here always we'll try to accept the null hypothesis, reject the null hypothesis. So, if at all table calculated value is less than our table value, we'll accept the null hypothesis. So, we'll say that the samples has dragged out of population mean. So, this is how we'll give the decision for the sample test. So, test statistics after obtaining the test statistic, will consider that as a calculated value and will try to give the decision whether to accept the hypothesis or reject the hypothesis. So, this is the formula and this is the concept of t-test for obtaining the single mean. So, let us check once again what is the formula. This is the formula to obtain our single mean. In t-test we obtain. So, because it's a small sample, we have a degrees of freedom. So, n minus 1 degrees of freedom will consider. And then according to the formula, we'll substitute the values and we'll get some calculated value, and based on that, we'll go for the conclusions. That is, we'll make the decision whether to accept or reject the null hypothesis. So, this is the concept of single mean in t-test. So, hope you have understood this session. See you all in the next session. Thank you.